Hi, Anupam.
Yeah, hi, Prasad.
Yeah. So can you just brief me about yourself?
Yes, yes. Myself, Anubhav Bech, I'm currently working in Philips over 3.8 year of experience in like
Mm-hmm.
automating pipelines, Kubernetes operation, and like cloud infrastructure. If you come to my like
Mm-hmm.
day-to-day like activities, so first activity like monitoring and alert handling basically. So we have to monitor the pod health, infrastructure usage, and also like service uptime using Prometheus,
Mm-hmm.
Grafana, this kind of things. And come to like CI/CD pipeline. So we are basically using this Jenkins. So we have to create and maintain like a multi-bunch Jenkins pipeline with like
Okay.
support artifact function. We integrate these things with SonarQube for like code quality check, and Tree we are using for the image vulnerabilities. And our pipeline is basically fully parameterized for handling this DFQ and pod environments. And
Mm-hmm.
Kubernetes section, we are basically using this EKS cluster. So
Mm-hmm.
we have deployed and managed like different microservices in AWS EKS. So we have to write and maintain like Kubernetes manifests, like this deployment services, ingress, a config map, yeah. And now for incident section, so basically we are using the service max as well as like a Jira. So we have to respond those incidents through like Jira and Smax ticketing systems. And for automation section, we are using basically Ansible. So we have to write Ansible playbook. Also, we are using this Python and also like this uh, sales scripting. And come to like cloud section. Basically, for cloud, we are using this AWS. So we have to like work and producing like managing AWS resources like EKS cluster, EC2 instance, S3 IAM role, RDS, this kind of things. And for Terraform, we are also using, we have to write this Terraform scripts to like automate this our EKS cluster setups and also like VPC configuration, this all kind of things.
Okay. So you worked on VPCs, right?
Yeah.
Okay. Can you just explain the components in VPC?
Yeah, so inside VPC we have like different components. So first like you have to like create this VPC, and inside this you have to create this like gateways, and also like NAT gateway you can use over there. This VPC basically like it's a virtual cloud. So if I means explain from the beginning is how to you have to create. So first we have to create this CIDR block. So you have to define your range, means how many like IP address you want. So first that you have to define this like IPs range by CIDR blocks. Then you have to set up your subnets. For you have to divide these things by a logical division of your VPC. Okay, so like public subnets or private subnets that you can use. Okay, and you can also like each subnets you can also belong with like different means one availability zone. Okay, then it's come like route table. So you have to define this route table, means where our traffic goes. So that you have to maintain by route table. After these things done, and for route table, this is basically for public subnets. You have to give this internet gateway. And for private, if you are using private subnets and you want these things, then internet, then you have to use the NAT gateway. Okay, so after that you have like internet gateway. So we have to like we have to basically enable these things for between a VPC and internet connection. Okay, so you have to do these things like internet gateway. Okay, after that you have to NAT gateway also I explain. And then you have to second like yes, security groups. So means this is one kind of like firewall, like virtual firewall. So you have to enable the security group with ports. Okay, and then if you want more security section, then you can also define this NACL, basically network access control list NACL. This is like a subnet level firewall. Okay, you can also do these things. Yeah, so this is the basically main components of like if you're talking about like VPC.
Okay. So NAT gateway, in which subnet is it created?
NAT gateway.
In which subnet is it created?
NAT gateway basically is for like your private subnets. So if you want like internet connection to your private subnets, so for that means you can enable this NAT gateway, private subnets basically.
Give me 1 second.
Yeah.
Okay. So, yeah.
Hmm.
Have you worked on EC2 instances?
Yeah, yeah, easy to instance.
So, I have a machine in a private subnet. So, how do you connect to that machine?
Okay, so if you have your machine means ETC instance is in like a private subnets. Okay, Bastion host you can use. Okay, by use first you have to means log into your Bastion host, and from there you can access your private EC2 instance.
Okay. So, in security group, which port do I allow and for which IP address do I allow?
Means come again.
In security group, which port do I allow and for what range do I allow?
Port we have like a 22 port for SSH, right? And
Mm-hmm.
you can allow this from your Bastion host IP address.
Okay. Okay. So, have you created EKS clusters?
Come again.
Have you created EKS
Yes,
clusters?
EKS cluster. Yeah, we are basically we are creating this EKS cluster by this Terraform scripts basically for automation
Mhm.
purpose.
Okay. So, through Terraform, you create an EKS cluster. Okay. How do you create a role for an EKS cluster? What kind of roles does an EKS cluster need?
Role basically uh, a roles perspective mean like you are talking about this service these things.
No. When you create cluster,
Okay, okay. This like yeah. So basically, create like this role like for EKS cluster role. So basically, for control pan and EKS node. So basically, we have to create this IAM role policy. So we have to go to this IAM role. Then your role section, you create one
so
role.
what kind of policy does an EKS cluster need?
The policy name is Amazon, like Amazon cluster role policy, something like that. I'm not able to recall, but this is the policy. Means you have to attach this policy like Amazon EKS cluster policy for your
Okay.
EKS cluster.
So, the node group you create,
Hmm.
how do you create a node group?
Means worker node, right?
Yes.
So by Terraform only you can create, but if you're talking about like how manually you can create, so basically for that means you have to attach different policies. Okay, like Amazon EKS worker node policy we have. Then for CNI policy also we have like then if content registry policy you can have. So this kind of policy you have to allow for this
Okay.
worker node.
Okay, those are fine. When you create a node group, what all parameters do you define while creating a node group?
Parameter basically so what parameters we need to allow. Yeah, so we can allow like um, basic configurations, something like you have to give this cluster name and node group name and like IAM role name, this kind of things. Also you can allow this AMI type, what AMI you want to use, this also. Then instance types also, then how much disk space you want to use, like how much EBS volume, so that we have to define.
Which which AMI do you use while creating a cluster?
Basically we are using basically this Ubuntu only, so I'm not able to recall AMI name, but Ubuntu system we can use it basically. So something like uh, mm, 64 something, I'm not able to recall properly right now, but yeah.
Okay, so you told you worked on deployments and everything, right?
Hmm.
Okay, so what is the difference between a deployment and a stateful kit?
Yeah, so both are different things. Deployment basically, see what deployment will allow. So deployment helps to like it will replica set. So it will create replica set by using this replica set. Spin up your pods. Okay, and also in this is one deployment section. But if you want to have a stateful sets basically using for the database purposes. So for stateful sets, it gives different features to us. So first features is naming convention. So all your pods going to be a same name. Okay, so same name, it will spin up your pods. And if you means suddenly you can delete one pod, so it will be reproduce same name. So this is one features. Okay, and then second feature is like so there you have like if you spin up three pods, like three replica sets, and it will make one pod like master. So this pod have like read write facilities. Okay, and others two pods like read facility. Okay, these features also gives, but if you wanted to spin up this stateful spot by manually, so only naming convention they will give you. But if you using this persona xdb, so this all the features you have, this kind of features, so it will help. And like they will give like different EVS volume also, like different spot, there are different storage.
Okay. So how is the service on a pod connected?
Services they we have like a label and selector. So okay, okay, by that way, so this service is connect with your pods. We have label and selection. Okay, you have to define your label and selector in your like deployment. Okay, and also the same label and selector you have to define, you know, service, so that service will able to identify, okay, this service goes to these pods.
Okay. What is liveness and readiness?
So LifeNet and readiness basically, LifeNets basically it will check like your pod is alive or not, means able to take the it able to take your what do you call, like service, means yeah, service or not. So it will defined by the liveness prop. And readiness prop means I'm not able to recall right now, but readiness prof, yeah, this is help for these things only, but I'm not able to recall this readiness prof, liveness prof, these things only. But readiness prof only, yeah, readiness prof basically it takes like your pod is able to take the traffic or not, for that.
Okay. So have you worked on Ingress?
Yes, yes.
So how do you create Ingress?
Okay, so for basically for ingress we are basically is using basically ingress controller. Okay, and this controller you basically use, and in ingress file you have to set up your like all that like you have different microservices. Okay, so like pathway starting you have to put over there, like for for these things we have to go our traffics for these microservices and these microservices. Basically if you are creating ingress, so this is one kind of traffic rule book. Okay, and ingress controller basically it will allow those rules basically. So like that way this ingress and ingress controller will help. And for if you want like http and http services, so that's why you can also use this tls. Okay.
Okay. So when you're using Nginx Ingress controller, which kind of load balancer does the Ingress creates?
Application load balancer, basically we are using basically application load balancer for like we are handling this http and http services.
Okay. 1 minute. So AWS has its native Ingress controller. Which controller is that?
AWS will provide like mm, yeah, AWS application ingress controller, something like that. AWS have their own if you wanted to use for AWS section. So
Okay. So
like
when you create Ingress with Nginx Ingress controller, does it create a load balancer in AWS?
I don't know, but I read somewhere that that time like cloud will create one like network load balancer they will create for like network load balancer for
Uh,
cloud provider create.
so how is the traffic being routed in your existing infrastructure?
Mm, means can you explain means
So your applications are hosted in Kubernetes.
hmm,
So how are you connecting? How is the application getting the traffic?
by load balancer?
Okay, load balancer. Okay, fine. So, which load balancer is getting created and how is it getting created?
Mm, okay, so how it will mm, first basically, so we have to install this Nginx controller. Okay, so then we create basically the service type like mm, yeah, so like first means we have like service types like load balancer, so they will create like a cloud will provide your network load balancer basically. So means mm, if I means explain like first kubectl cloud controller, we have like
Mm-hmm.
kubectl cloud controller, so which is manage this the traffic which is detected. Okay, then like some API call will be happen by I think means some AWS API call will happen. So like this is basically like provide your load balancer. Okay, then if you have like this load balancer DNS name, so then it will be like by that way I think this goes to your any ingress maybe.
Mm-hmm.
First we have means first like internet, so from internet we access. Okay, then it will come under your like AWS load balancer, like whatever load balancer is there. Okay, then it goes to our like Kubernetes nodes, then it's come to our we have kube proxy. Yeah, we have kube proxy over there. Okay, from
Mm-hmm.
there it will be go to your like pod container maybe. This way like maybe traffic flows.
That is all fine.
Hmm.
So, I just wanted to know, will it create application load balancer or a network load balancer?
For we are basically using this application load balancer only.
Application load balancer. When you so how is it? Do you define it in service or do you define it in ingress? So how is the load balancer getting created?
Mm, we I think define in our service section only maybe.
Okay. When you define load balancer in the service section, will it create a network load balancer or application load balancer or a classic load balancer?
Mm, if we create this service, so maybe network load balancer it will create.
So when it is creating a network load balancer, how will HTTP and HTTPS traffic flow through network load balancer? Because HTTP and HTTPS traffic is an application level.
Okay, okay. Means like if you means basically like a service, if you will use this load balancer, so it will create one network load balancer. Then it's come under like Nginx ingress controller. Okay, and Nginx ingress controller also, but there this network load balancer. Then I think then it's come under like application load balancer.
How will your service create two load balancers there? You're telling it will create a network load balancer and ingress controller comes into action and it creates application load balancer. Why is the need of two load balancers there? And how is it interconnected?
Mm, mm,
Okay,
hmm.
that's fine. So basically, I have an application hosted in a private machine. It's totally a private configuration. So how will I make it accessible to others? So
Mm,
you take Google as an example. Google is an application.
hmm.
So Google is hosted in my private machine in a private architecture. So how will you make it accessible to the world?
Mm, by make it like this. We can make the service service like load balancer service. So for that means we can access this via like internet. Means Kubernetes service we can use the service type load balancer.
You live from Kubernetes perspective. I have an application hosted in my private machine.
Hmm.
I created EC2 machine. I hosted Google there, and it is in a private subnet. So how will you access it? How will you access it from outside?
Mm, okay, so public, private. So mm, we can use load balancer over there. We have
Hmm.
a classic load balancer, application load balancer. So that we can use, and we can
So which load balancer will you use?
uh, for like accessible HTTP and HTTPS, we can use application load balancer.
Okay. So for when creating an application load balancer, what all do you check and what all do you create?
Come again.
How do you create application load balancer?
So we'll create means we can create this application load balancer, and there we can define our target groups, and then we
Mm-hmm.
can use this by target group we can create over there. Then we can by that way we can create application load balancer. Means we can set up the target group.
Okay. Mm. Can you just briefly explain me about the three-tier architecture?
Okay, so for theta architecture means how I define this theta
Yes.
architecture.
How do you create a three-tier architecture?
Okay, so theta architecture. Mm, so for theta architecture, we have a front end uh, okay, so for that, for theta architecture, we have three things front end, back end, and database section. So first, I will create for theta architecture, I will set up first VPC and subnets. Okay, then after that, I will create this internet gateway, NAT gateway, this kind of things. Okay, then network NACL rule I have also create. Then security group, security group basically how I will create. So I will make this web tier, means which is allow whatever port like 880 or 443. Okay, then application tier I will allow if it's like 8080 port. Okay, from web tier. Okay, then for DB tier, whatever DB you are using, so that things will create. Okay, then I will privilege those things, and then I will make this web tier in public layer. Okay, I use ETSU instance. It's like auto scaling groups. Okay, and I will make it two availability zone for high availability. Make it for two availability zone. Okay, and behind in I will use one application load balancer. Okay, okay, for this is for
Mm.
our web tier. Okay, and also for target group also I have to attach this application load balancer, which is mapped to our EC2 instance. Okay, whatever port you want to use, whatever port you wanted to use. Okay,
Mm-hmm.
like 80 or something. Then I will come under application tier. Okay, I make this, I deploy this EC2 instance, I have to running in the private subnets, this
Mm-hmm.
application tier. Okay, and I will also this is for the and for if I use this application load balancer, I'll also define our own target group. Okay, which is if I wanted to use health check and all those things. Okay, these things
Mm-hmm.
done for the application tier. Then I come to our database tier. Okay, in database tier means whatever you can use, if use MySQL. Okay, or if you wanted to use RDS, so you have to maintain is multiple availability zone. Okay, so these kind of things. Okay, and I place this these things with private DB, private subnets. Okay, and also if you wanted to intent, you can use this NAT gateway and all those things. By
Okay.
this way I will create these things, and also more security purpose you can also use this IAM role. Okay, and
Mm-hmm.
for monitoring you can use this CloudWatch and all those things.
Okay. Yeah, okay. And I'm done with your interview. If you have any questions, you can just ask me.
Yeah, so basically, which cloud we are going to focus more? This like hybrid cloud we are using, or we are more focus in AWS?
It is with AWS and GCP. We use
Hmm.
both here. And yeah, it's totally into infrastructure as a product-based company,
Hmm. Hmm.
wherein we create our in-house product and we host it totally in the AWS and GCP here. More all our services are in Kubernetes.
Hmm.
So we have to maintain Kubernetes. So basically it's totally an infrastructure-based role wherein you create, you maintain, you take care of the application uptime and everything. Yeah, so
Okay.
that's how it goes.
And any on-premises services we have?
Right. Then we have a product-based company,
Hmm.
so it's all our in-house product.
Okay. Okay.
And we host it in AWS and GCP, and then we give it to the customers.
Okay. Okay.
Yeah.
Got it. Got it, sir.
Okay.
Yeah.
Thank you.
Thank you, sir. Thank you.